As an engineer working on cloud, you are starting with a new VPC in your cloud infrastructure. You are tasked with creating a couple of subnets for your front-end application, having two subnets, each with 512 IPs. You start diving into address arithmetic and create two new CIDR for the subnets. And after digging into the IP arithmetic, you create new CIDR with prefix /23 for your front-end applications. So the new CIDR would be like 10.118.32.0/23 and 10.118.34.0/23. After a few days, you get new requirement for creating two more subnets for your backend applications of the same size 512 and three subnets for databases of the size 256 IP each. You again start diving into IP address arithmetic, which could be an exhaustive process since you might have to recall the logic and entire arithmetic again. How can you efficiently calculate and create these subnets without diving into IP address arithmetic again and again? Because it can cause a lot of cognizant load. Before we plunge into the nitty-gritty of this solution, let's quickly recap what subnetting is all about. Subnetting is a fundamental concept in networking that allows us to divide a large IP address range into smaller and more manageable chunks. This not only helps with IP address management but also improves security and resource allocation. As you probably know, Terraform is super useful tool of the infrastructure world. It enables us to define our entire network architecture as code, bringing us flexibility, repeatability, and collaboration like never before. Terraform not only allows you to create the infra as a code, but it provides a function like CIDR_subnet, which helps you to memorize your logical concept about IP address calculation. CIDR_subnet function is like a Swiss Army knife for network addressing in Terraform. It allows us to dynamically calculate subnets within a given CIDR block. Just imagine the possibilities. Now let's break down the syntax of CIDR_subnet. It goes like this. The name of the function is CIDR_subnet and the parameters that you need to pass is base CIDR, new subnet bits, subnet index. The base CIDR is your starting CIDR range. The new subnet bits determine how many bits are allocated to the new subnet, and the subnet index specifies the position of the subnet within that range. The most important idea is that an IP address is fundamentally constructed from binary digits, even though we conveniently represent it as either four decimal octets. For example, in the above case, CIDR subnet 10.118.32.0/19 with parameters as 40, the function will first convert the given IP address string into an equivalent binary representation. The /19 at the end of the prefix string specifies that the first 19 bits or the first two octets and 3 bits of the next octet of the address identify the network, while the remaining 13 bits in this case identify hosts within the network. When we call CIDR_subnet, we also pass two additional arguments, new subnet bits and subnet index, which decides how much longer the resulting prefix will be in bits. In our example, here we specified 4, which means that the resulting subnet will have a prefix length of 19 plus 4 equal to 23 bits. We can imagine these bits breaking down like this. 4 of the 5 bits of third octet that were originally the host number are now being repurposed as the subnet number. The network prefix no longer falls on an exact octet boundary. So in effect, We are now splitting the last decimal number in the IP address into two parts, using half of it to represent the subnet number and the other half to represent the host number. To convert this back into normal decimal notation, we need to recombine the two portions of the third octet, converting 001000010 from binary to decimal gives 34, which can then be combined with our new prefix length of 28 to produce the result 10.118.34.0/23. The new subnet has 4 bits available for host numbering, which means that there are 512 host addresses available for assignment once we subtract the network's own address and the broadcast address. So now we have got the formula to create first subnet. We can easily create more subnets just by incrementing the subnet index number until it hits the max index within the next 4 bits, where new subnet bits equal to 4 bits. So we can quickly calculate our front end and back end subnets. Since we need a subnet with /25 prefix to have 128 IP in each subnet, we will pass new subnet bits equal to 5 and subnet index will start from 24 to avoid any conflict with our existing subnets. So essentially, CIDR subnet 10.118.32.0/19 and with subnet bits equal to 5 and subnet index equal to 24 will give us our first database subnet. Now let's put all of these pieces in Terraform code to create the subnets. In our module, we create an AWS subnet resource named private, and we pass certain standard AWS parameters such as VPC ID, CIDR block, IPv6 CIDR block, and some others just to complete the parameter list. But the most important parameter that we are passing is the private CIDRs, since we are focused on the function CIDR subnet. So if we local.vpc CIDR with the parameters 4 and 0, it will give us our front-end subnet. And by incrementing the second parameter, we can get our second front-end subnet. Now let's run the so we are getting two new subnets for the front end. Now let's add some new subnet configuration in our. So our updated configuration would look like this, where we are configuring two additional backend subnets and 3 database subnets with the different parameters. Now let us run the Terraform again. So now we are getting some new subnets for the backend and the databases. Before I wind up this video, I would like to tell about one more best practice that we need to follow. We should always create the Terraform CIDR config in a map variable rather than any index and use the for each loop in our module to iterate over the CIDR subnet. This gives us the flexibility to remove any subnet from the configuration without any impact on the other subnet. That is all for today. If you got to learn some new concepts about subnet and you got some value from this video, please like the video and subscribe the channel.